Hello again, Ben here, and welcome back to my channel. So today is Saturday, August 1st. It's a little bit rainy, unfortunately, but we're here again in our field for our next video. So what we are going to do today is a little bit different than the videos past. So it's video number 21 already, which is crazy. Thank you guys for watching. And what I'm going to do today is talk a little bit about the basics, who I am, what I'm doing here, and how you can help if you're interested. So hang on, and I hope you enjoy. So I suppose first things first, who am I? So my name is Ben. I founded this company called CarbSec back in 2021, and the sole purpose of this company is to help fight climate change. So obviously there's a lot of CO2 in the atmosphere, and the goal of, there are many things that have to be done to fight climate change, obviously, like reduce the amount of CO2 that we're putting out into the atmosphere, but the purpose of this company is to help undo it by taking CO2 from the air and putting it back into the ground. And how you can see that we are doing it, obviously behind me, is we are using biomass. So specifically Miscanthus giganteus is this hybrid grass here that you can see behind me. This is about 7 feet tall or so currently. In places, obviously it's less in other places, but rain like this will certainly help it to get larger, which is good. But the whole purpose of this is that this grass is very efficient at taking CO2 from the atmosphere and putting it into biomass, which is a lot easier to handle than CO2 straight from the air itself. So when I first started, I was actually making or looking at direct air capture techniques, so taking CO2 straight out of the air, but those are very energy intensive and they are also very expensive, so not quite ideal for what we are attempting to do here. For scale, I'm 6 feet tall, and this grass is probably a foot taller than I am already. So it's probably about 7 feet tall in places. So it'll end up about 12 or 13 feet tall in ideal conditions. These are, this soil here is not perhaps completely ideal, but it's certainly good enough, obviously. So, and why I'm doing biomass is that it just helps to concentrate the carbon for me. So the whole purpose of what we're doing here, as I said, is to take CO2 from the atmosphere and put it underground. And it's a lot easier to handle biomass, like a solid piece of grass, than it is to handle CO2 from the air. And what you may not know, actually, is that biomass itself is actually quite efficient when it comes to moving CO2. So most biomass itself, if it's completely dry, is about 45% carbon by weight. And obviously we're talking about CO2, so carbon plus 2 oxygens, meaning that actually biomass itself, if you were to take like 1 pound of biomass and it's completely dry, it has approximately, or if it's 45% carbon anyways, 1 pound of biomass means that you have 1.65 pounds of CO2 equivalent in your hand. Which, if you were to do the math, assuming 425 ppm of CO2 in the air, you're talking about 1 pound of biomass has the same amount of carbon in it as approximately 51,000 cubic feet of air. So like a cube about 37 feet on a side has the same amount of CO2 as 1 pound of biomass, which is very, it's a lot easier to work with, obviously, 1 pound of leaves or branches or sticks or whatever than it is to have to, pump 51,000 cubic feet of air through air contactor and sequester it and do all of that. Not to mention that when I first started direct air capturing, most of those technologies are just taking it out of the air. You still have to figure out what you are going to do with it. So the whole purpose, like what I'm doing with CarbSec here basically, is just taking these very productive grasses, letting them grow, sequester all this carbon in a solid form, and then at the end of the year, they will senesce, they will die off all of their above ground biomass that will then, is cut down, densified, and then turned into charcoal, and that charcoal is buried or used for improving soil or stuff like that. So that not only sequesters not only captures the carbon from the air, but it also locks it away permanently in biomass that you can bury, return to the soil, and it is locked away for hundreds of years, which is why, we're doing what we're doing, basically. This is our first field that we have so far. Obviously, there is some, empty space in here still, but it is filling up over time. Each of these clumps that you see was one rhizome, one individual root piece that was planted 3 years ago that has then become, as you can see right there, like 12, 13, 14 stems, and they will eventually grow and spread until they are all the same density here approximately. And then they will, continue to grow and make more and more carbon captured every year using very little nutrients for about 20 years or more, which is why it's very nutrient efficient. And you only have to till up your soil one time and then leave it for a very long time. What's also nice is that these leaves also do, when the top senesces in the fall, what we're actually turning into carbon is the stems, and all of the leaves will fall off, lay on the ground, act as a natural mulch to inhibit weed growth, while also breaking down and improving the soil itself, adding more carbon to the soil that will help to improve the soil as well. This is, as I said, our first field. This is about probably 0.2-ish acres. I haven't really measured it. It's a little bit of an irregular shape, but we planted this with 1,000 rhizomes back in 2024 in the spring, and this is where we are currently. A lot of this over here was not very well fertilized, which I did improve on this year by adding some additional fertilizer, which has helped to make it a little bit better. We had some phosphorus deficiencies and stuff like that. One of the issues that we have with Miscanthus itself is that it's sterile, which is both a good thing and a bad thing. Good in that it's not invasive, so it doesn't make any seeds that can spread and go into places that it shouldn't be in. Unfortunately, that also means that it's hard to propagate, which is why I said I bought rhizomes, which are basically just like little root pieces that go in the ground and grow over time. So it's like vegetatively propagated. It's not, has no seeds, which would make it a little bit ideal, honestly, if it did, because that would be easier to spread, but it does not. So what people do usually is they will take a field like this, they will let it grow for several years, and then they will harvest it and take the individual root pieces, separate them, and replant them, and then that is how you can propagate it. So one root piece, as I said, as you can see here, becomes 10, 15, 20, up to like 30 or 40 individual pieces, like individual stems, and then those all make a bunch of rhizomes underground that are little root pieces like ginger, turmeric, that kind of thing, that you separate and replant, and you can, get a multiplication factor of about 30-ish after a few years, which is not nearly as high as seeds, unfortunately, but it's still pretty good. Since we're here anyway, I figured I would show you guys our last experiment that we did. And again, that was the horizontal stems with the rooting hormone on the left and the vertical stems with rooting hormone on the right. And I said that I wouldn't show you anything unless there was something to show, and there actually is, surprisingly, so let's go take a look. So as I was walking through here, I assumed that everything was dead, as I told you in the previous video, but actually you can see right here, for instance, is one rhizome, or not one rhizome, one stem coming up from the ground. So this is from one of our horizontally planted stems with the rooting hormone on it. You can see that it actually is growing decently well. And then close by we have another one here. So there's actually two out of a lot, obviously, so it's not necessarily a great propagation technique, but we have 1 and 2 Miscanthus stems that are producing some leaves. So not a great way to propagate, but it has some growth at least. As I said, we are using charcoal because that will lock away the carbon for hundreds of years. Obviously, if you just bury some, pellets, some wood pellets or some leaves in the ground, they are going to both decay very quickly and also decay mostly into methane, which is actually a lot more potent of a greenhouse gas than CO2 is, which is the antithesis of what we're trying to do here, which would not be ideal. So full process is plant rhizomes year 1. First year you get no harvest at all. Second year you get a little bit of a harvest like we had this previous year. Unfortunately it was too wet. And then third year on you get a much better harvest. So obviously if you saw this last year, it was a lot less dense than it is now. Still a lot to go, certainly, but there's a lot more here than there was last year. It's really starting to fill in the spots, which is nice. And then after you harvest it, as I said, you wait until it dies off in the winter. All of the leaves fall off, act as mulch on the ground, and then you harvest the stems. This will be hand harvested this year because I don't have a mechanical harvester, and also because it's small enough that you won't need one necessarily. I am going to buy a true hammer mill to make it a fine ground powder, basically, like, you know, very fine mulched biomass, and then I will take that powder that is also about 15% moisture content, make that into wood pellets to pelletize it, because the denser it is, the less space it will occupy, and how you turn it into charcoal is you heat it in the absence of oxygen, and it gives off all of its water first, and then it starts to carbonize, which makes it more stable. So charcoal you can bury underground or, you know, use to amend soil, and it'll stay there for hundreds of years, locking away that carbon, which is the goal. So you know who I am and you know what my goal is. One of the things that you don't know necessarily is like how I'm doing it and how you can help potentially. So I do make these videos not so much for entertainment. I mean, obviously you find them enjoyable and I appreciate you watching them, but they're more informative, more to track the process and stuff like that. But eventually YouTube, you know, is a source of income if you get more than 1,000 subscribers, and like each view, you know, helps to grow the channel. So what I'm doing is any revenue that I end up getting from YouTube will go straight into carbon capture, straight into helping scale this as a business. And then anything that I get from the business for now is also going straight back in to help scale it up. So if you are interested, you can certainly subscribe to the channel, like it, do all of that stuff that everybody always asks you to do. So in this video, I covered a little bit about who I am, what I'm attempting to do, and how you can help if you're interested. So hopefully you learned something, and if you have any questions, like I said, please leave them in the comments below and I will answer them for you. Otherwise, thank you for watching, and I will see you next time.